Look up at the night sky. Those twinkling lights are stars, but not all are created equal. Each one is a distant sun, burning with its own unique color, size, and story. Some are so faint you can barely see them, while others blaze with a brilliance that outshines everything around them. Some are small and red, quietly glowing for billions of years. Others, like our sun, shine with a steady yellow warmth. But the true giants of the cosmos are the blue stars, colossal, dazzling, and rare. These cosmic behemoths are the universe's powerhouses, burning with incredible energy. They light up entire regions of space, shaping the galaxies around them with their intense radiation and stellar winds. But what makes a star blue? It's all about temperature. These stars are the hottest in the universe. Imagine heating a piece of metal. At first it glows a dull red, then orange, yellow, and finally a blinding blue-white as it gets hotter and hotter. The color tells you just how much energy is being released. Stars follow the same rule. Red stars are the coolest, yellow stars like our sun are warmer, and blue stars are the hottest of all, blazing at temperatures that defy imagination. Blue stars can reach over 25,000 degrees Celsius, making our sun look tame by comparison. Some even soar past 50,000 degrees, radiating energy at levels that would vaporize anything nearby in an instant. Imagine a star so massive and hot, it shines millions of times brighter than the sun. If you could stand on a planet orbiting one, the sky would be bathed in an eerie blue glow, and night would never truly fall. These are O-type or B-type stars, true cosmic titans, often over 20 times the sun's mass. They're rare, but their influence is enormous, shaping the fate of entire star clusters. Their immense mass creates crushing pressure, fueling a furious nuclear furnace deep within. The result? A star that lives fast and dies young, burning through its fuel at a staggering rate. That's why they burn so hot and bright, but also why their lives are short and spectacular. In just a few million years they exhaust their fuel and explode in cataclysmic supernovae, seeding the universe with heavy elements. Now imagine getting close to one. What would happen if you fell into a blue star? The journey would be unlike anything you could ever experience on Earth. This isn't just about heat, it's about facing the most extreme forces in nature. The radiation would tear atoms apart, and the gravity would stretch and crush anything that dared to approach. Buckle up, let's take a one-way trip into the heart of a blue star. We're about to cross the threshold into a realm where the laws of physics are pushed to their limits. What awaits is a journey into unimaginable heat, radiation, and gravity, a place where only the most powerful forces in the universe reign supreme. Our sun is a G-type star, average in every way. It's stable, reliable, and has been shining for billions of years, providing the gentle warmth and light that makes life on Earth possible. But in the grand tapestry of the cosmos, the sun is just one of countless stars, and many are far more extreme. Blue stars, though, are anything but average. They are the true giants of the stellar world, dazzlingly bright and impossibly hot, standing out in the night sky with their electric blue glow. Their key difference? Mass and temperature. Blue stars are many times more massive than our sun, and their surface temperatures can soar to over 40,000 degrees Celsius, several times hotter than the sun's. Blue giants are the monster trucks of the cosmos, burning through fuel at breakneck speed. Their immense gravity squeezes their cores, causing nuclear reactions to rage at a furious pace. Despite having more hydrogen than the sun, they live only a few million years, a cosmic blink. While our sun will last for about 10 billion years, blue stars burn out in a fraction of that time, living fast and dying young. Their intense heat means they emit huge amounts of ultraviolet radiation. This energy floods their surroundings, making blue stars some of the most energetic objects in the galaxy. Any planet nearby would be blasted by radiation, making life as we know it nearly impossible. The fierce ultraviolet rays would strip away atmospheres and scorch surfaces, leaving barren, lifeless worlds in their wake. Blue stars shape their surroundings, carving out vast bubbles in interstellar gas and dust. Their powerful stellar winds and radiation sculpt the cosmic landscape, triggering the birth of new stars and dispersing heavy elements. Their deaths are as dramatic as their lives. As they run out of fuel, blue stars become unstable, swelling and pulsing as their cores collapse. While the sun will quietly fade, a blue star ends in a cataclysmic supernova. This explosion is so powerful it can briefly outshine everything else in its galaxy. For a brief moment, a single blue star's explosion can outshine an entire galaxy. The energy released is almost unimaginable, sending shockwaves across the cosmos. These supernovae are among the most violent events in the universe. They forge heavy elements, scatter stardust, and can even trigger the formation of new stars in nearby clouds. Blue stars don't just live fast, they die spectacularly, leaving a legacy of creation and destruction. Their remains enrich the galaxy, seeding it with the building blocks for planets and life. Their story is one of extremes, from their violent birth in stellar nurseries to their explosive end as supernovae. Blue stars are cosmic engines of change. Let's see what it's like to approach one up close and witness firsthand the awe-inspiring power of a blue star. Picture yourself in a futuristic spacecraft heading for a blue supergiant, let's call it Icarus Prime. The journey through deep space is long and lonely, with stars as sharp, silent points of light. As you approach, Icarus Prime grows from a pinpoint to a blinding blue disk. Even from light weeks away, its brightness dwarfs thousands of suns. Your ship's filters struggle to protect you from the glare. Radiation and stellar wind intensify, battering your vessel. Closer still, the star fills your view, a roiling, turbulent ocean of plasma. Giant flares erupt, sending loops of plasma millions of kilometers into space. The gravitational pull grows stronger, drawing you in. Your ship's systems strain against the heat and energy. The sense of isolation deepens as communication delays stretch. Now, the star dominates everything, a boundless, incandescent abyss. The journey ends here. The plunge is about to begin. What happens next is beyond anything you've ever experienced. Imagine stepping outside your ship in a hypothetical suit, facing the blue star's fury. The sheer scale of this star is almost impossible to comprehend. Its surface burns millions of degrees hotter than our sun, and its light is so intense it feels like a wall pressing against you. The light isn't just bright, it's a physical force pushing against you with radiation pressure. Every photon slams into your suit, making it feel as if you're being battered by an invisible, relentless wind. Shadows are razor-sharp, sliced by the unfiltered blue-white glare. Colors around you fade, washed out by the overwhelming intensity, leaving only stark contrasts and harsh outlines. The heat is overwhelming, penetrating from every direction. Even the most advanced suit can't keep up. The energy seeps in, cooking you from the inside out. Your suit's cooling fails instantly. It glows, then vaporizes. The protective layers peel away atom by atom, unable to withstand the onslaught. Gravity accelerates you toward the star, but tidal forces begin to stretch you apart. The difference in pull between your head and feet grows with every second. This spaghettification pulls you longer as you fall, your body distorting in ways that defy human experience, stretched thinner and thinner by the star's immense gravity. Radiation here is lethal. X-rays and gamma rays shred your DNA in microseconds. No material can shield you. The energy tears through every cell, erasing the blueprint of life. The invisible storm of energy is far deadlier than the heat or gravity. It's a silent, invisible killer, saturating the space around you with deadly power. Before you even reach the surface, you've received a fatal dose millions of times over. Your dosimeter maxes out instantly, unable to keep up with the onslaught. The star's pull is inescapable. You're past the point of no return. No force in the universe can save you now, as you're drawn ever closer to oblivion. Every force, light, heat, gravity, radiation, conspires to destroy you. The universe's most powerful energies are focused here, working together in perfect, destructive harmony. The laws of physics seal your fate in spectacular fashion. Around you, the cosmos puts on a display of unimaginable violence and beauty, a final testament to the power of nature. There's no turning back. You're about to become part of the star itself. The final descent begins, and in these last moments, you witness the raw, unforgiving power of the universe up close. A star's surface is the photosphere, a turbulent layer of plasma. Crossing this boundary, you plunge into a seething, superheated fluid. There's no splash, just instant assimilation into the stellar inferno. Your suit vaporizes, atoms are stripped of electrons joining the plasma. You're engulfed in blinding blue-white light, no shadows, no up or down. Pressure rises rapidly, crushing from all sides. It's like diving into an ocean of fire, with pressure increasing 1,000,000 times faster than in water. The star's atmosphere churns with convection currents and colossal sound waves. If you could hear, it would be a deafening, universe-shaking roar. You're no longer an observer, you're part of the star, pulled ever deeper. The journey to the core continues. You fall into the radiative zone, where energy moves by photons bouncing endlessly. Here, temperatures soar to millions of degrees. Pressure is unimaginable. Your body and suit are long gone. Now just a cloud of fundamental particles. You're indistinguishable from the star's own plasma, swept along by internal currents. The density here dwarfs anything on Earth. Pressure is millions of times greater than our deepest oceans. Your atoms are bounced around, absorbing and emitting energy in a cosmic pinball machine. Some may stay deep for thousands of years, others may rise back to the surface. Your journey as a person is over. Your atoms begin a new cosmic chapter. The timeline of your destruction is swift, less than a blink. In a microsecond, heat and radiation vaporize you into superheated gas. Your atoms are ionized, becoming a glowing plasma. Chemical identity is lost. You're now raw atomic material. As you fall deeper, temperature and pressure climb into the millions. Nuclear physics takes over, but your atoms don't fuse. Yet. Instead, you're mixed into the star's plasma, scattered like dye in water. Within a second, your particles are spread kilometers apart. You're not just destroyed, you're completely assimilated. You have become the star. Zoom in on a single carbon atom from your body as it plunges toward the core. In the core, temperatures reach hundreds of millions of degrees. This is where fusion happens. Your carbon atom could join the CNO cycle, helping fuse hydrogen into helium. It's a direct participant in the process that powers the star. Your particles are now part of a cosmic dance, forged and reforged in the stellar furnace. This is the universe's ultimate recycling. When the star explodes as a supernova, your atoms are scattered across the galaxy. They may become part of new stars, planets, or even life. In a real sense, you become part of the universe's next chapter. Falling into a blue star means annihilation, but blue stars themselves are cosmic creators. They forge the heavy elements essential for life, carbon, oxygen, iron, inside their cores. When they explode, they seed the galaxy with these elements, fueling new stars and planets. Their energy and winds shape galaxies, triggering new waves of star formation. Blue stars are engines of change, driving the cycle of birth, death, and rebirth. When you see a blue star, you're looking at a cosmic forge, the ancestor of worlds and life. Even in destruction, blue stars are part of a grand cycle of creation. The universe's most extreme events are also its greatest sources of renewal.